side's right. What are we going to do before that?
Before.
Yeah. After?
Oh.
What was that before? Take out the beat first.
What if you don't have enough time?
Stop the what? What do you mean?
What do you don't have?
Now, one thing, y'all be quiet. One thing you'll see, and this happened on an assignment you had last week, and I was talking to Grace about this. Lots of times when triangles are labeled, the angles are going to be the capital letters, and the sides will be that corresponding lowercase letter. So, like, look down there in the right angle where the C is. That'll be your capital C, and then the hypotenuse straight across from it will be a lowercase c. Up there on the top, there's your capital angle B. Straight across from it, a lowercase b. That's how those go lots of times. Our first couple of problems that we have, the directions just say solve the triangle. I got a little bit of info to give you on this one. Angle B is 28 degrees and 40 minutes. And then I know side A is 25.3 centimeters. And the directions say solve the triangle. That means find everything that's missing. So if we go through there and look for stuff that we don't know, we got to find angle A, we got to find side C, and we got to find side B. It's up to you to decide how you're going to start. If I were working this on my own, since I know two angles, I would find the third, because I know that three angles of a triangle have to add up to 180. So you got 90, you got 28 degrees and 40 minutes. Figure out what the other one needs to be to make 180. Let me know when you got it. Put it in degrees or degrees minutes, either one.
But do we need to have it, like we go to mode, go to degrees of radian?
Yeah, yeah. What'd you get, Rachel?
61 degrees and 20 minutes.
61 degrees and how many minutes?
20.
20 minutes. I think if you put it all as degrees, it was like 60.2 or something like that.
61.3.
61.3 Okay. Now, that got us our angles taken care of. Now we got to use our sides. Find our sides. If I were you, it would make most sense, because I got to have an angle theta I'm going to work with here. It would make most sense to make angle B theta. Why would it make better?
You had all the angles that you get one second.
Well, but that's 61 degrees and 20 minutes. You left the minutes off. 28 degrees and 40 minutes. It goes above. That would give you that extra degree. And you know that because look, 40 minutes and 20 minutes is there you go. All right, why would it make best common sense for me to use angle B instead of angle A? Because it was given, so it means I didn't mess it up. Because it's possible that I make a mistake with angle A and get it wrong. Then if I use that, I'm going to get my next answer wrong as well. So like Rachel said, angle B was given, I just copied it down. I'm less likely to make a mistake with it. So from angle B, we know the adjacent side. So you just need to pick now, do you want to find C or B first? Doesn't matter. Pick, okay, so we'll find C, that's hypotenuse, right? So which trig function uses adjacent and hypotenuse? No?
Cosine.
Cosine, very good. So we'll say the cosine of 28 degrees and 40 minutes is equal to adjacent over hypotenuse. Now this one's a weird one to solve because the C, what you're looking for is on bottom. So I always try to get you to envision that as a proportion there. Put that over 1 and cross multiply. You're going to have 25.3 is equal to C times the cosine of all that stuff up there. Squiggle, squiggle, squiggle. So what would you do to get C all by itself? Right. Divide by that stuff. Right. So what you're typing in your calculator is 25.3 divided by the cosine of 28 degrees and 40 minutes. And your calculator can handle all that. So get that all typed in there.
Do you still want it in like degrees and minutes?
No, this is just centimeters, so just round it to the nearest tenth will be fine. Because this is a side length. What'd y'all get on it?
I got 27.0. Yeah, no, I'm not weird.
I got 28.8.
28.8 is what I got. Look and see what y'all did different on that.
At 28.8.
Oh, parentheses, yeah. Alright, so now we're still missing side B. You could, you know, two sides now, so you could use Pythagorean Theorem. But the only dilemma I would run into if I did that is what if I got my C wrong? And now I'm using it to find B. My B is going to be wrong also. So even though I'm real good at Pythagorean Theorem, I'm not as good at trig, and I could have got 28.8 wrong. So I'm not going to use that one now. I'm going to stick with my trig functions, and B, side B, from angle B is opposite, right? So I got opposite and adjacent, which means I'm doing the tangent of side B, of angle B. Tangent of 28 degrees and 40 minutes is equal to opposite over adjacent. Now this one's a little bit quicker to solve because your variable's on top. So your variable's being divided by 25.3. To undo that, you just multiply by 25.3. So our B is going to equal whatever 25.3 times the tangent of 28 degrees and 40 minutes is. So how long is side B? Y'all got all that?
I got 13.83.
That is good. I'm going to round it just to 13.8. I like it. Okay, everybody all right? Now we started that one off with two angles and one side. We're going to do another solve the triangle problem where it's a difference. They're going to give us two sides and one angle, so we've got to work different on it. So I'm going to get my triangle drawn again. I hate this thing only has an equal lateral or isosceles. I want them to be scalene, but oh, I don't want that one down there. There we go. Alright, I got side A over here is 29.43 centimeters. I don't know angle A. Here's my 90. Side C is 53.58. I don't know side B, and here's my angle B. Alright, so this time we know two sides. Last problem was different. We knew two angles in the beginning. This time we know two sides. What do you think we'll do to start when we know two sides? What would make very good? Zane, Pythagorean Theorem would be the best way to go on this. We got one side, we got a hypotenuse, so we got to find the other side. So that would set up as 29.43 squared plus, I don't know, squared is equal to my hypotenuse squared. Okay, and then you're solving that for B. So whatever 53.58 squared is minus whatever 29.43 squared is, and then you square root it to get your B. Shout me a number.
44.77.
44, huh?
Well, that's what B equals.
Make sure I got everything written down right. 29.43, 53.58. The key is saying Well, that can't be right, because that's the,
You didn't unsquare it, like the square.
Uh, oh,
You didn't do
okay.
anything on the square on the B. You just said do those and subtract them.
Oh, so he had-
So
he had
the
a
B is still
square.
squared.
I think he squared, yeah, he squared it. So we're gonna say about 44.77.
Yeah, that's what I got.
Okay, the answer in the book, 44.77, is incorrect because it says side B is 55 point something. Well,
Yeah.
that can't be possible if your hypotenuse is 53. So that's craziness. Okay, so we got all our sides now. We got to get to angles. So pick an angle, A or B. Which one you want to find first?
B.
All right, B. Let me put a big old yellow dot up there on B. Maybe. All right. I would not use the 44.77 because that's what I found and I'm prone to mess up. So from angle B, the ones that we were given are your adjacent and your hypotenuse. So that would be which trig function? Adjacent and hypotenuse. Cosine, so I got the cosine of B is equal to adjacent over hypotenuse. I started to write the wrong one. 53.58. Alright, so I would go ahead and get on the dry erase board so we don't jumble up our picture. I would go ahead and divide that, 29.43 divided by 53.58. What'd you get when you divided that?
0.55.
Alright, now you can't just hit cosine of 55 on this one. This time we don't know the angle. There was a special step we had to do when we were solving for the angle. Remember what it was? Inverse. Remember when you're looking for the angle, you'll do second cosine, the inverse cosine. So you're going to get second cosine to bring up that inverse, and then 0.55. And I'll tell you what your angle B is.
6.63.
56.63 degrees. Alright, so we know a triangle adds to 180, and we now got two of the angles, but I wouldn't use that because what if we messed up again? I can use that to check myself in a minute, but I would go ahead and say, okay, now we need angle A. So let's jump down to angle A and put a big green dot on it. From angle A, 29.43 is opposite. So now I've got opposite and hypotenuse. Which trig function uses opposite and hypotenuse?
Sine.
So we got the sine of A is equal to opposite over hypotenuse. So it's the exact same numbers. We just changed to sine instead of cosine. So if you divide those, you're going to get the 0.55 y'all told me. So I've got the sine of A is equal to 0.55. So since I'm looking for an angle, I got to do that inverse sine of 55. And what do you got?
33.36.
Degrees. That's it.
We'll be 37.
Wrong.
I'm sorry. Oh, it's a 10. And I forgot. It's a 7. Be 37.
That's all right. She got it. She got it. Okay. All right. Now, before we got two more problems is all to look at, but before we get to them, we got to know a couple new, a couple of old terms we got to be refreshed on. So, everybody got what we need on this stuff? All right. Two different types of angles here. This would be the horizontal, supposed to be. Since I drew it and it looks bumpy, I'll label it. There's my horizontal side. This is called an angle, A-N-G-L-E, an angle of elevation. Okay, because from the horizontal side, we're measuring up. So that's how my pea brain remembers that, an angle of elevation. Then what about Now do you remember these? What about it from the horizontal? Here's my horizontal side. What about it from my horizontal side? I measure down. Do you remember what kind of angle that was called?
Angle of depression.
Very good. Depression.
We should have learned that.
Very good. We started talking about that first period and I had to send 2 people to the counselor. One of them said depression is not a thing to joke about. I'm thinking, I'm not joking. I'm trying to get you some help. And they didn't like it. Anyway, so those angles could be moved, flipped, written different directions, pointed different ways, but it's always based off of the horizontal one. So a lot of these problems that we're going to look at, like the ground would be your horizontal side. If we're measuring like the shadow of a tree, remember those are common problems, shadows of flagpoles, the ground will be your horizontal. So we might have to move those around, but it's always based off of your horizontal side. Okay, so first one we got here is a flagpole. No, so it's a tree. My bad. I was looking at a picture of a flagpole. I thought I'd hit turn page. Waiting on it to turn around. Page. Alright, so I got my tree. I always like to draw a lollipop tree. It says the angle of depression from the top of a tree to a point on the ground, 15.5 meters from the base of the tree. So let me label that first. There's 15.5 meters. That's also my horizontal side. But it said the angle of depression. Okay, so I know here I could drop a hypotenuse there, right? But I still don't have an angle of depression on that. So what you have to be able to visualize to complete this thing, I'm just going to do all my extra stuff as dotted, could be the rest of the rectangle there, right? So here, this is green I think, here, why is it not highlighting? There. Here would be my angle of depression. Okay, so it says the angle of depression from the top of the tree to a point on the ground, 15.5 meters, is 60.4 degrees. So that little green angle up there is 60.4. Now that's not really in the triangle that I need though. So what would I do to find out, and you can't see it through my beautiful tree that I drew, what would I do to find out this angle?
Subtract from 90.
Very good. I made a right angle there, my rectangle. So 90 minus 60.4 would give me this angle that I need. What's it? 29.6. So that angle, draw it way down here, is 29.6 degrees. So I believe the question said, what's the height of the tree? I've lost track of that. Let me double check. Yeah, find the height of the tree. So from that 29.6, my tree would be adjacent, and my 15.5 would be opposite. Which function has adjacent and opposite?
Tangent.
Tangent. So I got the tangent of 29.6 is equal to, of opposite over adjacent. Now we had one set up like this earlier where your variable was on bottom, and what did you actually end up having to do to solve that? Cross multiply, and then what? You're right. Because that's equal to x times the tangent of 29.6. So we had to divide by the tangent of 29.6. And how tall is our tree?
27.28.
Okay, 27.28, and this was meters. Very good, very good. Okay, we got one more in just a second where we've got a flagpole. Also, a tree and the flagpole are pretty common. A ladder leaning against a house is a common one. We'll look here at the flagpole next. Are you good on that? Alright, the length of the shadow of a flagpole. So you've got to start by drawing your flagpole. Length of the shadow of a flagpole is 55.20 feet. 55.20 feet. The length of the shadow of the flagpole. Oh, I read it wrong. I've already screwed this up. The length of the shadow. Do what? Yes, it's the length of my flagpole. Thank you. The length of the shadow of a flagpole, 55.2 feet tall. So there's your flagpole, like Zane said. 55.20 feet tall, is 27.65 feet. So this shadow is 27.65 feet. Now we got it labeled correctly. Find the angle of elevation. So we drop this here. Angle of elevation to read upward from your horizontal. Don't even have to do any extra stuff. It would just be right there. Right? So in this case, again, I've got opposite and adjacent, so it's the same function again. You got that one down yet? Tangent of angle theta, I don't know it. That's what I'm trying to solve for this time. It's equal to opposite over adjacent. Okay, so go ahead and do your division this time. Tangent of theta is equal to 1.99. I rounded mine out of my book to 6 on that, but because if you're going to have a hard time distinguishing from 2 on that one for real. But all right, this is like the one that I still have over there on the dry erase board. Now we're looking for tangent of an angle, so we got a special extra step to take. We do the inverse tangent, and that'll give you the angle of elevation. What do you got?
63.4.
You got it, sister. 63.4 degrees. Okay. All right. Just got last thing that we're going to look at. So I'm going to go back like the ones we started on, where we were asked to solve the triangle. But I'm only going to ask you for one piece of it, and you're going to answer that in your classroom. You don't have to do the whole thing like we did on the board. Just got to do one piece of it. Alright, my hypotenuse is 964 meters. Angle C is my 90-degree angle. Angle A is 36 degrees and 20 minutes. All you have to find is side A. You do not have to solve the whole triangle. Just find side A. I've not pushed the button to send it yet. I will do that while you're working. Probably so. So when you get ready, you know to be there.